Hello. This time we will create a new robot. It will come with some simple default behavior and I will just go over that. Then I will start a battle with the new robot. First we select the robot menu and then the source editor. The first time this opens you have to specify the Java version. You should already have Java installed and Robocode should find this. So just click yes and then OK. And now to create a new robot, click File here in the robot editor, then New and select Junior Robot. This will give us a fine starting template. First I pick a name for the robot, choose something cool. Then I have to choose a package name. I just type in trainee. In your assignment it is specified what the package should be, so all robots are usable. Then OK, and here we are. Let me just maximize the window. And let's have a look at the code. First we have the class name as I just picked. It extends Junior Robot. This will allow us to override the below 4 methods which will define the behavior of the robot. We will also get access to some data like the robot's heading and the heading of the gun, along with other interesting stuff. We will get to this in another video. Notice there's no constructor. If you create one, your robot will just be destroyed every time a round starts. So we cannot create a constructor of any kind. Whatever initial setup you need must be done in the run method below. So first we have the run method. This is the main behavior of the robot. The run method is called continuously by the Robocode application. In most examples, the run method contains an infinite loop to control the robot. However, you don't need this. Whenever the run method is finished, the application immediately calls the run method again. So you sort of have an infinite loop anyway. But using a while true loop is probably fine, but you do have the other option, just to be aware of that. I can't say if one is better than the other, but maybe you will structure your code in a way which causes you to have a preference. The first piece of code here will set the colors of your robot, like body, radar, scanner, turret, bullets, and so on. I don't really remember which argument is which, but you can find that in the documentation, or if you use IntelliJ, you can probably see it from the names of the arguments. And then the actual behavior encapsulated in an infinite loop. The ahead method will move your robot 100 pixels forward according to its current heading. Turn gun right will spin the gun clockwise a number of degrees. Here the argument is 360, making it a full circle. The radar follows the gun by default, so to turn the radar you have to turn the gun. There is a method to separate gun from radar so they can move independently, though it may not be available on the Junior robot. Then back up 100 pixels and then turn the gun in a circle again. Next we have 3 event methods. These are automatically called by the application when something happens. The first is the onScanned robot. It is automatically called when your radar scans an opponent. Whatever code you put in here is executed independent of what happens in your run method. Sort of. I assume you queue up actions to perform like move, turn, shoot, and so on. So this method will allow you to add an action to the queue. One action is then executed and must finish before the next can start. So if you move 100 pixels, you can quicker get to the next action, whether that's move another 100 or scanning for other robots. Compared to if you just move 500 pixels, then you're kind of stuck in that action until it finishes. I'm sure this is explained in the documentation somewhere, so maybe my observations here are not entirely correct. There are inherited field variables to get information about the scanned robot, like what was the heading of your gun. I will cover this in another video. Then on hit by bullet controls what should happen when your robot is hit. Here we just back up a little bit. And lastly, what should your robot do when you hit a wall. Again, we have inherited field variables, which tells us the position of your robot and the size of the battlefield. So before you move your robot forward, you could check whether this move will actually cause a collision with the edge. Now we need to save the robot, which requires that I have changed something, so I will just add a line to this comment here. Then I can save it. First time it will just confirm the directory, so that's fine. I can then verify the Java file is actually there. Okay, then I need to compile it, so I get a class file. This is what the Robocode application needs to run my robot in a battle. Select compiler and then compile and success. Now I want to test my robot. I close or just minimize the editor and create a new battle. I can find my robot under the package name I chose, and I will just add a simple opponent here. And here's my robot moving forward, spinning the gun, back, spin, and so on. You will notice the gun shoots forward. I think that's because you tell your robot to perform an action like move, and then when that action is done, it can do the next action. So you have a queue of actions, as I mentioned earlier. If you remember the code, the method call to fire the gun happened in the event method on scanned robot. I guess we're just queuing up that shot, but is then executed after the entire full rotation. So not really an amazing robot, but we're just starting out.